So why isn't the sine of a plus b the same as the sine of a plus the sine of b? Algebraically, we talked about that a little bit at the beginning of the last lecture. It doesn't work for the analogy to multiplication to carry over to function notation. There's no guarantee that that will happen. And in fact, it couldn't possibly happen for the sine function, because if you consider the sine of a, pick a to be an angle where the sine would be bigger than a half, pick b to be another angle where the sine is bigger than a half, then the sine of a plus the sine of b would be the sum of two numbers bigger than a half. The answer would be bigger than 1. And yet we know that the sine function is trapped between -1 and 1. Its range is from -1 to 1. So whatever the angle a plus b is, its sine, the sine of a plus b, couldn't possibly be equal to the sum of the sines of the individual angles. What works is something a little more subtle, but it's really bound into the geometry of the unit circle. If you track what's going on for sine and cosine in terms of chords, lines that you draw from point to point in the unit circle, you can come up with a formula for sine or cosine of a sum of angles, sine of a plus b, cosine of a plus b, or a formula for sine or cosine of a difference of angles, sine of a minus b, cosine of a minus b. And that's what we're going to work on today.